we will begin by converting the mixed number to improper fractions. So there's our first one, and of course we are identifying the different parts of the mixed number. We have the whole number, we have the numerator of the fraction, and we have the denominator of the fraction. First, we multiply the denominator by the whole number. 7 times 1 is equal to 7. Then we add 1 to the result. We add the numerator to the result. So 7 plus 1 is equal to 8. So 8 will be the numerator of the improper fraction, and the denominator will be the same. Identifying again the parts of the mixed number. Then we multiply the denominator by the whole number. 2 times 2 is equal to 4. Then we add that 4 to the numerator. 4 plus 1 is equal to 5. 5 is the numerator of the improper fraction, and the denominator will be the same. We will perform the subtraction making use of denominator. So we will subtract. We do the subtraction process here and make use of the denominator right here. So instead of using this original, we are going to use the one with the mixed numbers converted to improper fractions. And we are going to perform this subtraction. But before we do that, we need to make note of the fact that in this expression, what we have done is that we have taken the lower set of fractions right here, and we have used, instead of this bar or this line that we have here, which means that we are dividing the upper set of fractions by the lower set of fractions. So we have included a division sign instead of the bar that we have right here. Also, it is important that we enclose the upper set of fractions in brackets. And that is because if we did not have the brackets right here, the division operation would have precedence over the subtraction. So we would have to divide 3/4 by whatever the result that we have right here. We would have to do that first. But that is not consistent with what we had before. What we had before is that the upper set of fractions will be divided by the lower set, and that has to be indicated right here. Also, it would not have been completely necessary to enclose this set of fractions with brackets, because multiplication and division take precedence over addition and subtraction. So this set of brackets would not have been necessary, but they are putting together the lower set of fractions, making our intention much clearer than if we did not have them. So, making use of the common denominator, which is the smallest number that both 7 and 4 can divide into without leaving a remainder. And that number is 28, which of course is the lowest common multiple of 7 and 4. We say then 7 into 28 is 4, and 4 times 8 is 32. The subtraction sign is going to be placed right there, as we have right here. Then 4 into 28 is 7, and 7 threes 21. Reduce the fraction by a common factor of 5, then invert and multiply. So we have this fraction can be reduced by a common factor of 5. If that is done, these 5 will cancel each other. Then we will have 1 over 2, or a half. But dividing is equivalent to multiplying by the inverse or the reciprocal. So instead, we will multiply by 2 over 1. So these 5s are cancelled and we are left with 2 over 1. As a matter of fact, we'll be left with 1 over 2, but we are taking advantage of the fact that dividing by a fraction is equivalent to multiplying by its inverse. So we have inverted the result right there. So let us simplify the numerator that we have right there and continue to reduce the fraction by a common factor of 2. So 2 will go into 28 and 2 will go into 2. So we will have, for our result, 11 over 14. We have another situation in which we are required to calculate the exact value of the expression that we have right here. We will clear the decimal fraction by multiplying both numerator and denominator by 100. That is an approach that we can take, but students may opt to use different approaches. So we multiply the denominator and the numerator of this fraction by 100, clearing the decimal fractions. So we now have 2 minus 24 over 15, and we then reduce the fraction by a common factor of 3. 3 into 24 is 8, and 3 into 15 is 5. So we have 2 minus 8 over 5. And of course, 8 over 5 is equal to 1.6. So we have 2 minus 1.6, and that is equal to 0.4. The cash price of a bicycle is $319.95. It can be bought on hire purchase by making a deposit of $69 and 10 monthly installment of $28.50 each. We need to determine the hire purchase price of the bicycle. So in order to determine the hire purchase price of the bicycle, we add 10 times the value of each installment to the down payment. So we have a down payment of $69 and we have a monthly installment of $28.50. We'll add 10 times the monthly installment to the down payment, and the result is $354. Then calculate the difference between the total hire purchase price and the cash price. Of course, the hire purchase price is $319.95, and we need to find the difference between this figure that we have right there and the $319.95. So we subtract the cash price and the result is $34.05. Express this figure as a percentage of the cash price. So, of course, we are going to divide that figure by the cash price and multiply the result by 100. So we divide this result by the cash price and multiply the result by 100, and that is how we will express the result as a percentage. So we have there 10.64%. We need to solve the inequality that we have right there. So let's go straight ahead. We will just transpose this 3 to the other side by subtracting 3 from the right hand side. So we have negative 2y. With this 3 transposed to the right hand side, we have 7 minus 3, which is equal to 4. Then we will divide both sides by negative 2. So negative 2 will be eliminated from the left hand side, and we divide 4 by a negative 2, and the result is negative 2. In so doing, we are dividing through by a negative quantity. When dividing by a negative quantity through an inequality, we will change the inequality sign. So that is a requirement for the change of the inequality sign to the opposite one. So we'll change this sign to the opposite one because we are dividing through by a negative 2. So the result is y is greater than negative 2. The solution requires the smallest whole number that is greater than negative 2. As it is said there, if y is a whole number, determine the smallest value that satisfies the inequality. So here y is required to be a whole number, and that whole number must, as it is said right here, be greater than negative 2. So the smallest whole number that is greater than negative 2 is negative 1. So y is equal to negative 1. We will next factorize the expression that we have right here. Of course, we will take the common factor. The common factor is what is able to divide into x squared and also xy. So the common factor is x. So x is our common factor. So we will say x into x squared is x, and x into xy, the x's will cancel and the y remains. So we have x, and inside of that bracket we have x minus y. Now right here we have a difference of two squares. And of course, the CSEC examiners expect us to be able to write down the factors of a difference of two squares. So we will say, what do we square to give a squared? And that is a. And what do we square to give 1? And that is 1. So the factors will be a minus 1 and a plus 1. So write down the factors of the difference of two squares. We have a minus 1, a plus 1. And of course, if you put a plus 1, a minus 1, you are still correct, because the order in which we multiply two expressions or numbers does not affect the product. Next, we have a quadratic, 4 terms, and we are going to use factorization by grouping. We have 2p minus 2q, so we take the common factor of 2p and 2q. Of course, factorization by grouping, we are taking the terms 2 at a time. So 2 is our common factor, and we are going to say 2 into 2p, the 2's will cancel and we'll have p, and then 2 into negative 2q, the 2's will cancel and we have a negative q. So we will have in that bracket p minus q. We will then take the common factor of the other two terms, and we will use the sign that begins the second pair. So the sign that begins this pair is a negative sign, so we are going to take that sign. Along with the sign, we will take the common factor of the two terms. And of course, the common factor in this particular case is p, because p can go into p squared and p can go into pq. So the common factor in this case is p, and we are going to accompany that by the sign that begins the second pair. So this is our second pair. The sign that begins the second pair is a negative sign, so we are going to accompany that p with the negative sign. Then we will say negative p into negative p squared. Negative into negative is positive, so we will have a positive p. Then we will say negative into positive is negative, so we will have a negative q at the end. So we will have p minus q. One common mistake students make is that when they get right here, they have this negative sign, and then they say p into p squared p, and then they say p into pq, and they do not remember that while dividing the term by the common factor, they have to do that with the sign and all. So they forget about the sign and they put a positive q right here. End up with two different signs inside of the bracket, and then they start to panic. Well, it might still happen to you in an examination. So if that happens, all you need to do is check the signs and ensure that you have made the right choice of signs. The common factor in this particular case is p minus q. We can see that p minus q in the first instance and p minus q has a second occurrence right here. So we know that the common factor is p minus q, and the other brackets will be occupied by 2 minus p. The table below, we don't have it, there we have it. That table shows the types of cakes available at a bakery, the cost of each cake, and the number of cakes sold for a given day. Write an expression in terms of K for the amount of money collected from the sale of sponge cakes for that day. Of course, the amount of money is going to be equal to the number of them that was sold multiplied by the cost of each of them. The amount collected for the sponge cake equal to the cost of each multiplied by the number of them. So we have how many of them? 2, and we have k plus 5 is the cost. So there we have it. 2 multiplied by k plus 5. Right, that is just to see if we are able to get a little start in answering the other part of the problem, which says we need to write an expression in terms of K for the total amount of money collected. So for the total amount of money collected, what do we know? That we need to multiply as we have it in the first case, the cost of the cake by the number of each, the cost by the number of each, the cost by the number of each. So let's do that. So we will find the total by multiplying the cost and number of each, and by also adding the results at the end. So we'll do that in one statement. So we have 2 times k plus 5, we have 10 times k, and we have 4 times 2k, and we will add all of those together. The total amount of money collected at the bakery for the day was $140. So that total will be equal to $140. So there we have the expression being equated to $140. Of course, we have the brackets expanded, so 2 times k is 2k, 2 5s 10, and we have 10k goes right back, then 2 times k times 4 is 8k, and that is equal to 140. So we're going to put all of these k's together, we'll get 20k, and on the other side we have 140 minus 10 is 130. So 20k is equal to $130. So k is equal to $6.50. Here we have a universal set U equals the set of letters K, L, M, N, P, Q, and R. That universal set has 2 subsets, S and T. We are going to place those elements in this Venn diagram appropriately, and we will begin by inserting the elements that are common to T and S. So those that are common to T and S will go first. And that is what we will always do when we are completing a Venn diagram in which the universal set contains two sets. We will put the element in the intersection of the two sets first. So that is what we are doing right there. Putting the elements in the intersection of the two sets first. So K is the first one. Any more? Right, P. I don't imagine that we will have any other after P. Then we will insert the elements that are unique to S. Then those that are unique to T. And of course, not to be left out, those elements that are in the universal set but they are not present in S and they are not present in T. Any other? Well, that is the final one. And there we have our Venn diagram with all the elements included. List using set notation the elements of S union T. What do we mean by S union T? All of the elements that are in S and all of the elements that are in T. Let's put all of those together and that will be the set S union T. So all of those elements that we can see in that shaded region will be in the union of the two sets. So we have K, L, M, and then we have P and Q. Of course, it is always good to write the elements when there are numbers in numerical order, when there are letters in alphabetical order, and some may say because of information technology, write the elements in alphanumerical order. Next, we will write the elements of S complement. What do we mean by S complement? All of those elements that are outside of S. So, the elements of S complement are all those elements that are outside of S. So, we put that red circle over the entire set S. So, we can see all of those elements that are not in S. And they are in numerical order, in alphanumerical order, N, Q, R. For the diagram that we have, we will first attempt to determine the angle ABC. So ABC is the angle that we are focusing on. ABC. That angle ABC is the one that we are trying to determine. Now, what do we know? Because of the arrows that we have right here, AB and DC are parallel. So AB is parallel to DC, as we can see right there. AB is parallel to DC. BC is perpendicular to CD. So if BC is perpendicular to CD, don't forget that these two lines are parallel. And if this line BC is perpendicular to this one, it must also be perpendicular to the one that we have here. So AB is parallel to DC and BC is perpendicular to DC. Therefore, BC must also be perpendicular to AB. So the angle that we are trying to find, which is ABC, because AB must also be perpendicular to BC, the angle ABC is equal to 90 degrees. we need to find another angle ABD. So the angle ABD, that's not difficult. We know that this angle is 90 degrees and this one is 42. So this one is the rest of 90 degrees. So the angle ABC is 90 degrees. We have it right there showing that ABC is 90 degrees. One portion of that angle, which is DBC is 42 degrees. The other portion, which is ABD, must be what remains of that 90 degrees. So ABD is equal to 90 minus 42, which is equal to 48 degrees. Finally, we need to determine another angle, BAD. So BAD is what we need to find. So the marks that we have, those marks on the triangle ABD, so those marks that we have on the triangle that we have right here, so those marks on BA or AB and AD indicate that they are of the same length, although it is not obvious from the diagram. The diagram is not drawn to scale, but those marks indicate that the two sides are equal in length. If they are equal in length, we have an isosceles triangle. So the triangle ABD is therefore isosceles. So if this angle is 48 degrees, so is the one over here. So that one is also 48 degrees. So all the angles in a triangle add to give 180 degrees. We have no problem seeing that the angle BAD is what is left of that 180 with these two 48 degrees angle taken out. So we have BAD is equal to 180 minus 2 times 48, and that is equal to 84 degrees. John left port A at 8:30, well, let's say 08:30 hours, and travels to port B in the same time zone. So John left port A at 08:30 hours and travels to port B in the same time zone. He arrives at port B at 14:20 hours. How long did the journey take? The length of time that the journey took is the difference between the two times that we have right there, which is 07:30 hours and 14:20 hours. So we are going to subtract. In subtracting, we realize that we cannot subtract 30 from 20 immediately. So we will go to the hour section and rename 14. So 14, we take 1 hour from this part, from the hour section, and we have 13 hours left. Here, this hour is converted to 60 minutes. Then we may subtract, because we have 60 minutes and 20 minutes, so that's 80 minutes, and from that we will subtract 30 minutes. The result is 50 minutes. Of course, no problem here. 7 from 13, we have 6. So the duration of the journey is 6 hours and 50 minutes. We are now being informed that the journey is 410 kilometers. So we need to calculate the average speed in kilometers per hour. So we know the distance traveled is 410 kilometers. We need to determine the speed. And of course, speed is equal to distance divided by time. So speed is equal to distance divided by time. The speed is required to be in kilometer per hour. So the minutes have to be converted to hours by dividing by 60. So we will have 410 divided by 6. We have a fraction of an hour, which is 50 over 60. So we have distance divided by, and this is the time, 6 hours, and we have a fraction of an hour, which is 50 divided by 60. Of course, we can convert this to an improper fraction. So we are going to convert the mixed number to an improper fraction by saying 60 times 6, which is 360, and to that we'll add 50. So we'll have 410 over 60. So we have 10 divided by 410 over 60, which is something very pleasant to the eyes, since we know that we are going to invert and multiply those figures. Dividing by a fraction is equivalent to multiplying by its reciprocal. So we are happy that the figure turned out to be 410. So we may reduce the fraction by 410, and the speed turns out to be 60 kilometers per hour. The diagram that we have shows a circle with its center O and a square PQR, and the square PQR is not necessarily all inside of the circle, but it is right as we have it in the diagram. The radius of the circle is 3.5 centimeters. We are first required to calculate the area of the circle, and of course the area of a circle is given by pi r squared. So we have pi r squared. Use the formula for the area of the circle. The length of the side of the square is equal to the radius of the circle. So we have information there telling us that the length of the side of the square and the radius of the circle are equal, and that is going to be very important as we move to the other sections. So the area is equal to 22 over 7 multiplied by 3.5 squared, and that turns out to be 38.5 centimeters squared. Now we need to find the area of the square, and of course we know that the area of the square is given by the square of one side. So we're going to square the length of one side. So we'll have 3.5 squared. So the area is equal to L squared, which is the length of one side square. No problem with that. Area is equal to 3.5 squared, which is equal to 12.25. Next, find the area of the shaded region. The dark region is what remains when a quarter of the circle is removed from the square. So notice that it's a quarter of the circle that is moved from the square. See? A quarter of the circle is taken out of the square, and that is how we arrive at that shaded region. So what we are going to do to find the area of that shaded region, we are going to take out a quarter of the area of the circle, and of course we have the area of the circle right there already. So the area is equal to, of that shaded region, 12.25, which is the area of the square, and we are taking from the area of the square, we are taking a quarter of the area of the circle. So here we have in red quarter of the area of the circle, and of course we have the area of the square right there in blue. Subtracting, we get 2.625 centimeters squared. This is our statistics problem. And it says that in a survey, all the boys in a book club were asked how many books they each read during the Easter holiday. The results are shown in the bar graph below. And that is the bar graph that we have right there, and we are required to use that graph and construct a frequency distribution. In a graph of a frequency distribution, frequency usually occupies the vertical axis. The horizontal axis is occupied by the values in the data. So we have, those are the values 0, 1, 2, 3, 4. So they are the number of books, and they range from 0 to 4. The height of each bar will tell us the respective number of books read, and that will be our frequency, or equivalent to frequency. Notice that we have right here 1, 2. So the height of the bar is 2 units. So number of boys associated is equal to 2. There we have another bar that goes up to, as we can see, 1, 2, 3, 4, 5, 6. So the number of boys in that particular case is 6. Then the highest bar that we have, all the way up to 17, and that one up to 8. And that one is 1, 2, 3. Right. So there we have the table completed. How many boys are in the book club? For total number of boys, add the number in the appropriate column. So we have number of boys, we have a column, number of boys, right there, and the total number of boys will be the result of adding all of those numbers that we have there, and that is equal to 36. What is the modal number of books read? The modal number of books read. The mode is the number associated with the highest frequency, or the highest number of boys. So the highest number of boys, our frequency, is 17, and the number of books associated with that is 2. So the mode of the distribution is equal to 2. How many books did the boys read during the Easter holidays? How are we going to determine that? Let's see. How many books did the boys read in the Easter holidays? To find the total number of books read, multiply the number of boys by the number of books read by each boy. That makes a lot of sense. Then add all the results and see what happens. So we are going to multiply the number of boys by the number of books read by each boy, and then we are going to add the results and see what happens. So the total number of books read in the entire holidays. So we are going to make a transition to a jargon that most students might be familiar with. The number of books are values of the variable x, and the number of boys is the number of times each occurs, and that is its frequency. So in order to determine the total number of books read, we will multiply f by x. So we have a column that we use fx. So we have 0 times 2 is 0, 1 times 6 is 6, 17 times 2, 17 times 2 is 34, 3 times 8 is 24, and 4 3 is 12. And the total number will be 76. So that is what we have. Now we will calculate the mean number of books, and we are going to recall the formula that is used to find the mean of a frequency distribution. X bar is equal to the summation of fx over the summation of f, or divided by the summation of f. So x bar is the mean, that is equal to the summation of fx. What is the summation of fx? Here we have that 76, and the summation of f we have there 36, and that is equal to 2.11. What is the probability that a boy chosen at random read 3 or more books? Find the number of boys who read 3 or more books by first finding those who read 3 books. So we start at those who read 3 books. And how many do we have? 8. So 4 is the only number of books that is greater than 3. So we are making use of that 4, which is the only number that we have that is greater than 3. So we are saying 3 or more. We start at 3, then we move to more than 3, which is we have 4 is the only number of books that is read that is greater than 3. So find the associated number of boys. The associated number of boys is 3. So we are going to find the total of 8 and 3, and that is equal to 11. So the total number of boys who read 3 or more books is equal to 11. But we need the probability, so we divide that by the total number of boys. So we have 11 boys who read 3 or more books. So we need to divide that by the total to determine the probability that a boy chosen at random would have read 3 or more books. So the probability is 11 over 36. The diagram shows a pattern made of congruent right-angled triangles. In each triangle, the sides meet at right angle are 1 unit and 2 units long. So of course, this is 1 unit and this is 2 units. Right? So 1 unit, 2 units. We cannot forget that. Now we will describe fully the single transformation that will map triangle BCL that we have right here onto triangle FHL. FHL. What is the transformation that maps this triangle BCL on this one? The only transformations worthwhile considering are rotation and reflection. Of course, we know that it is not an enlargement because the statement of the problem says that we have a pattern made by congruent right-angled triangles. That means all the right-angled triangles are equal in all respect. That's what it means when we say that they are congruent. So we know that the right-angled triangles are congruent. So we know that it's not enlargement. We are sure that it is not translation because we realize that it is not looking exactly the same as we have it before. So in a translation, it will look exactly as we have it before, only that it will be at another location. So we know that it is not a translation. So we are going to consider a rotation or reflection. Of course, if it is a reflection, we should be able to identify some mirror line. The transformation is not a reflection because the lines joining points to their images are not parallel. In a reflection, the lines joining points to their images are parallel. So say this is F is the image of B. Notice that the line that goes right here from B to F, and also H is the image of C. So C, notice that this line goes here and this one goes there. They are not parallel, so we are sure that it is not a reflection. Now what do? We will rotate the triangle BCL until it is at the same position as FHL. So we have this triangle and we are going to rotate it until it is at this location. Okay. Each point is joined to its image by a straight line. So B to F. F is the image of B. Notice that we have a straight line joining B to F. And of course a straight line joining H to C. So angles on a straight line is equal to 180 degrees. So we are sure that the angle of rotation is 180 degrees. Also, this point here is invariant. That means it does not change. That means the image of L is also L. Therefore, L is the center of rotation. So the transformation is a 180 degrees rotation that is centered at L. And we have another transformation to describe. And that one is the transformation which links the triangle BCL to HFG. HFG. What do we know? That these triangles are exactly the same, except that this one is at a different location. Therefore, we know that it is a translation. Also, we need to be reminded that from here to here is 1 unit, and from here to here we have 2 units. So from here to here, 1 unit. From here to here we have 2 units. So everything about BCL and HFG are the same, with the exception that they are at different locations. The transformation is a translation. So we know that it is a translation. So we go down. Notice that from here, notice that this distance that we have here is 1 unit. So what do we know? 1 unit in the negative y direction, or 1 unit downwards. So we go 1 unit downwards. Of course, we are going to go all the way here now. The horizontal dimension is 2 units. Do not forget that from here to here is 2 units. And this one will travel from here. 1, 1. So this is the length of the base, and then we have another length of the base. So it travels all the way across there. So the horizontal movement is 2 of the horizontal dimension of the triangle. So we would have traveled by 2 horizontal dimension of the triangle. We know that a horizontal dimension is 2 units. So the movement would have been by 4 units. So we know that we have a vertically downwards movement, or in the negative y direction, by 1 unit, and a horizontal movement in the positive x direction, that is by 4 units. And that is the translation. Our duty now is to construct a parallelogram WXYZ in which WX is 7 centimeters and WZ is equal to 5 centimeters, and the angle XWZ is 60 degrees. So first draw the line WX is equal to 7 centimeters. 7 centimeters WX. That's it. The angle XWZ is 60 degrees. The middle letter is always the vertex at which the angle is located. So the vertex is located at W. We have a 60 degrees angle to construct. So put the point of the compass at W and make 2 arcs. Then remove the point of the compass to the point of intersection of the arc and the line WX and make another arc. That line that goes up from W to the intersection of those two arcs will make a 60 degrees angle with WX. Do not forget that it will be WZ and it must be 5.5 centimeters. So there we have it. We are going to complete the parallelogram now. The angle that we have just constructed, is XWZ. We have the points W and X already. The point at the other end of the line that we have just drawn is therefore Z. Next, construct the line that passes through Z and is parallel to and equal in length to WX. How do we do that? We will use construct number 8 in Richard James Mathematics Resources that we will find in Computations Part 2 and Geometry, which is of course not Volume 1 but Volume 5 of Richard James Mathematics Resources. So open the pair of compasses with the point at W. Open the pair of compasses with the point of the compass at W and the point of the pencil at Z. After that, we will remove the point of the compass to X and make an arc. We will then open the pair of compasses with the point of the compass at W and the point of the pencil at X. We will then remove the point of the compass to Z and make another arc. The point of intersection of the two arcs will be Y, and of course the parallelogram may be completed. Now measure and state the length of the diagonal WY. Measure, use the ruler to measure WY, and WY is equal to 10.7 centimeters. There we have a function y is equal to x squared minus 4x. And first, we are required to complete the table that we have right there. So let us proceed. Y ordinates are missing for values of x equal to 0, 3, and 5. So substitute the value 0 in the place of x in this expression that we have right there. So we will have y is equal to 0 squared minus 4 times 0. All zeros equal to 0. So no problem with that one. Do the same for x is equal to 3. So we have, of course, 3 squared minus 4 times 3. So we have 9 minus 12, which is equal to negative 3. And continue for x is equal to 5. So we have 5 squared minus 4 times 5. So we have 25 minus 20, and that is equal to 5. On the next slide, we will plot the points and complete the graph of the function. Negative 1, 5. So, negative 1, that's in the x direction, 5 in the y direction, and we put our point right there. And of course, our next point is 0, 0, and that is the origin. So we put that point right at the origin. And 1, negative 3. So 1 unit in the x direction and negative 3 units in the y direction. And our point goes right there. 2, negative 4. 2 in the positive x direction and negative 4. So 4 in the negative y direction. 3 in the x direction, a positive 3, and a negative 3 in the y direction. The point goes right there. 0, we have 4, 0, so 4 in the x direction, and there is no y movement, so we do not go up, we do not go down. The point goes right on the x-axis, where x is equal to 4. And finally, 5, 5. 5 in the positive x direction, and 5 in the positive y direction. And we will finish up by drawing the curve. We are required to draw the line y is equal to 2, which is a horizontal line that crosses the y-axis at 2. So the line y is equal to 2 is horizontal and crosses the y-axis at 2. There we have it. Y is equal to 2. Then we will state the coordinates of the 2 points at which the curve meets the line. So where do we see that the curve meets the line? Right there. And of course we are writing down the x values where the curve meets the line. So we have x is equal to negative 0.5 and of course 4.5. Hence, write the equation whose roots are the x ordinates stated right here. So we are going to write down the equation whose roots are solution. So the solution of the equation is x is equal to negative 0.5 and x is equal to 4.5. So that's the solution of the equation, and we are going to write down the equation with that solution. And of course, what equation did we solve? Well, we equated the curve whose equation is given as x squared minus 4x with the line whose equation is 2. Therefore, since we are equating the curve and the line, we will say that the equation of the curve, which is x squared minus 4x, is equal to the equation of the line, which is 2. So the values of x obtained are those corresponding to the points where the curve meets the line. Therefore, at those points, the line and the curve are equal. So x squared minus 4, that part belongs to the equation of the curve, and 2 belongs to the equation of the straight line.